what am I doing here? What are we doing? What are we trying to measure? The economic impact analysis steps, first of all, were fed by the information from the interconnection seam study. So as you saw Aaron's presentation this morning, you had model, feeding model, and now you're feeding my model. So we have a series of successive models here. So that increases our confidence in the results immeasurably. I translate that. I'm using an in-plan model. How many people here have either worked with or used in-plan? Maybe a few. In-plan's something that's got something of a shady reputation among some folks, but it's also the model that we've been using for the last 25 or so years. It's the most commonly used model by the federal government, a lot of state governments, land-grant universities, and I've been using it for a long time to try to describe economic change in regions. I use in-plan, by the way, because in-plan is completely transparent, completely modifiable. I can make it whatever I need it to be. There's no black box to it at all. It has limits. Those limits don't factor into what we were doing here. I also relied on existing NREL information to do this in the time period, and at the level that we're doing this, this is a higher level analysis. If I'm doing this kind of analysis for a project, I'd use different data than what NREL have. But I have NREL data, and I was able to use NREL data, and they have these components called JEDI, Jobs and Economic Development Impacts, that associate with different types of projects. I use a little of the information from that. I don't use the whole thing. I just use some of the information from that because it's from NREL and it must be good, right? I modify the model to the degree that I need to modify the model to accurately represent what I'm trying to study. In this case, it has to do with whether I have a probability of buying an input from the nation, probability of buying an input. And then finally, I generate and report the results. So that's basically the steps that I've gone through here. Now, I've got two types of economic impacts that we're going to measure, two types of economic effects, if we want to use that word as well. We have the temporary and project-specific that are associated with these vast amounts of investment that have been talked about here with regard to these studies. And they're temporary and they're project-specific. They last so long as the investment is being translated into construction activity. I get an estimate of the actual construction plus the supply chain plus the multiplied through effects, the induced or the household effects that are caused from workers spending their paychecks. We also have the ongoing operational effects. Once they've completed these activities, we now have a new facility up and running. We have capacity that's generating product in the economy. They're ongoing and permanent and ultimately cumulative. And again, we measure those. So first off, I'm measuring the economic value or the economic impacts or the economic effects associated with construction. And we also add to that the ongoing activity. As we learned already today, we have two scenarios. Scenario A is current policy. Current policy assumes no CO2 penalties and some renewable or no renewable portfolio standards. $40 billion in transmission, $50 billion in new investments in energy generation. Scenario B, which I learned today, is now called the carbon policy. I didn't have a name for it. We have CO2 penalties. That's $80 billion in transmission, $700 billion. I am going to analyze scenario A in this presentation with, at the end, some comparisons to scenario B. But primarily, I'm going to demonstrate what's going on with scenario A. Just for clarification, everything is in $2024 to include the modeling that I'm doing. Also, I'm using a national model. Even though these are large regional investments, I'm going to argue, at least at this stage of the analysis, that the supply chain demands are so diverse and so strong they have an impact on the entire nation. So there's no problem with me using a national model. If we ever get to the point where we want to do regional assessments, then we'll redo it with subsets of states. But right now we're using a national model. $2024, the model, and the inputs are all calibrated at the same space. So we have this flow of inputs, or flow of investments over time, and I have transmission investments, some up to the $40 billion. I'm not used to dealing in billions like this, but $40 billion of investments over a period of time. So I have a flow of these investments over time. I have the same thing with energy investments. I have it by category: wind, solar, natural gas. You can see, of course, that the vast spending, and that spending is occurring earlier on in wind, the amount in solar, natural gas, and when it's timed, as well as our totals right here. So these are the values that I need to sum everything to, and then these are the elements that I'm shocking within the model over different years. The process of translating this stuff into their information into in-plan, I want to go back. I use the JEDI spreadsheets. It's off-the-shelf kind of information, and it allows me to allocate my spending across several categories. So that's important, and I was able to use JEDI for wind, natural gas, and for transmission. They didn't have what I needed for solar, but they had other publications that were perfectly good, and I used them. Also, with regard to the solar, and this was in consultation with Jim, we decided that we were going to apportion it 70% utility, 30% household or residential, and 30% commercial. So there's some distributed aspects to it. I was able to get that kind of breakout into NREL, and I was able to create a weighted compilation for my solar sector. Okay, so I'm able to put that together. And here's an example, and I hope you can see this okay. This is for the wind sector. And again, these are highly aggregated categories, but again, we're at the high level of analysis, and we're still being able to shock these sectors of the economy and come up with estimates of impact. And you can see other plastic products. Well, of course, that's the blades, right? When I did this in the years past, I didn't use other plastic products. I used another industrial category. What do we know out there that makes large fiberglass objects? Boats. I used the boat sector, but now it's okay for me to use the plastic sector. I know how to modify it. Turbine and generating equipment. Of course, that's the nacelle. That's the top of that puppy. Labor, 16%. Transportation at 3.4%. So I have my other fabricated product, metal manufacturing, structural manufacturing, all these categories. Those are the things that we're doing. Okay, so what do we do? Well, it's a bill of goods approach, and I shock the model by each one of these categories. Each one of these categories, I shock the model by that much. How much did we spend of each of every wind, solar, or whatever? We shock the model by these specific categories, and we do this bill of goods approach. Then we put the labor income in there, and then we put it all back together so that it sums up to what it's supposed to sum up to. So this is a case where when you're doing this in in-plan, you can't just push the button in the model and write out the results and have the answer. You have to do a few extra steps. So that's what was done with regard to the construction impacts. Many of you people may or may not have an introduction at all to economic impact terms, so let me just take a minute here to talk about that. We have direct, indirect, induced, and total. The direct effects. If I'm operating a utility, that's the direct effects are the jobs it takes to run that utility, to produce the output it produces for the year. That's the direct effects. The indirect effects are the supply chain. It's feedstock, transportation, legal, environmental services, any number of input that it takes to run that operation. What did you have to buy from the rest of the economy to run that operation? The induced effects in economic impact analysis occur when people in the direct sector and the indirect sector turn their paychecks into household consumption, and they induce another round of economic activity. And as they induce another round of economic activity, they create jobs in the induced sector who turn around and buy things in the economy. You add it all together and you get the total economic impacts. We have 4 categories also in terms of economic output that we look at and that we measure. The first one is industrial output. That's just simply the worth of what you made or produced over the course of a year. It's a big number because it is the biggest number. It's the number that people pay attention to, but it's just a bunch of churn. What we really want is the value added, but I'll get to that in a second. Labor income, wages, salaries, plus the value of all benefits that we derive from working. So that would be your health care and everything else. Value added, it includes labor income, but it also includes all returns to investors, plus what's called indirect tax payments. Now, value added is the same thing as GDP. So when I'm talking about something producing a gain in the economy, I don't look at the industrial output. I look at what that churning does to create value added, because value added is GDP, and GDP is how we measure the economy. So that's the number I look at. Last of all, we have jobs. And again, they're just jobs. They're full-time, part-time, seasonal jobs. However many jobs are in that industry, that's what it is. It isn't full-time equivalencies. It's just jobs. So those are my economic impact terms. So we run this through the model for every one of these sectors, every single one of these sectors, wind, solar, natural, gas. And one of the things I'm doing right off the bat here is I need to do two things. First of all, I got the information biennially. They have every 2 years they have an investment value. Well, I need to annualize that information because input-output models and impact studies should be, the results should be declared on an annual basis. We don't sum results up over several years and then say we have this great big number. That's wrong. People do it all the time, but it's wrong. So I have activity going on then in 2024 and 2025. You can see it's in 2-year pairs. Each year, my initial construction activity would generate this kind of jobs. And by the way, I'm only talking about the construction jobs right here, not the supply chain jobs. And then here's the labor income jobs. Here's that divided in half annual project spending. Now, the reason I'm putting these up, these actually constitute a big component of the direct values. Also, I pull these out specifically because when you're trying to sell a project politically, you got to sell the construction jobs. And we learned that in the Dakota Access Pipeline and some other things. When you want to sell something, so here's the construction-only jobs. Here's their labor income. This is the total project spending. So let's multiply some of this through and see what we end up. This is a peak year of activity. This was the peak pair of years of economic activity. It was 2028, 2029. I think I'll go back one. Oops, I need to go back, the other back. $48 million right here, $48 million worth of project spending in each one of those years. In spending $48 million, they generate, again, here's the supply chain jobs. That's labor that's associated with the construction, plus all of the jobs supported in the supply chain, plus all of the labor income, the value added, and again, the gross output. Here's the induced activity when people spent their paycheck. You sum those all up, you get the total. And so what did I get? I got $104 billion worth of churn in my economy that yielded us $53.2 billion worth of value added, of which $36 billion was labor income that went to 564,000 jobs in the economy in each of those 2 years. In each of those 2 years. This is the stream then that gets produced, so we do it for wind. Solar had an interruption, and then it finishes out. Natural gas is up front. Transmission is relatively consistent, but picks up. You can see the jobs, and then we sum to the total. And here's what it looks like if I graph it out. So here's the wind jobs, and they're substantial. And I add to that then over time. And they're occurring in the first 2/3 of this time frame. And again, remember, I'm adding one more year because of the construction, smoothing out this on the construction side. Here are the solar jobs. Natural gas occurs earlier on. You can see the jobs that would be created by constructing those structures and systems. And then we have transmission jobs that got added to the total. So this is our scenario A. This is what our job creation looks like. You add it up to the total, and it's well over 550,000 jobs per year each of these 2 years. A lot of jobs. So I can have a summary of this. I can summarize this, and we can try to put it into context. Again, each year annually they'd be spending 36-point-something billion in investments. This is what would be so the annual average of output would be 73 billion. Of that, almost 38 billion would be value added. Of that value added, 25.1 billion is labor income. 389,000 jobs are supported. And then of that, about 20%, a little over 20%, 84,000 are construction only. Now, Jim asked me to put this into context. And I said, I don't know how to, well, okay. So the average number of jobs created in the United States from 2009 through 2017 was 2.3 million jobs. This level of job creation would amount to about 17.4% of that value. That's a huge, huge amount. And that would be a very strong stimulus to the national economy. Now, that's not saying that the national economy could have grown by that much more, because if you're investing in this, you're not necessarily investing in that. We have opportunity costs. We have choices that get made. But the point is, it is a big number. It is a big number. All righty. Once these things get built, then they have to be operated. And so we have the economic effects, or the operations impacts. And these effects, they're ongoing, they're durable, they're cumulative up to the point of we built the last one of these things, and then they level off. And again, I measure that with input-output models. Now, this was a little bit more straightforward. It's not quite as, well, it's more straightforward in the sense that it's more conventional in the way that we did that. But I had to get some information. First of all, and you won't be able to see this, but the Department of Energy has a nice current chart that tells me how much energy is generated by source. So I have fossil fuel by category, nuclear, renewables, several other categories down there. The in-plan model has several categories as well in terms of they've subdivided their power generation into these several categories. They have. So because I already know the number of jobs in that sector for the year that I built the model, and I know how much energy is produced in those broader sectors, then I was able to calculate per 100 megawatts of production some factor. Because now what am I doing? I'm increasing my generation. So if I'm increasing my generation by some value, I simply need to multiply it times this number to get my value that I need to shock. So I'm shocking my model by jobs. That's all I'm doing. I'm shocking my model, my current model, by jobs. And what I'm telling my current model is, well, what the current model is telling me is that we're using the economy as it's currently configured to describe this economic activity, not some future, because we don't know what the relationship of jobs or output or anything else to production, energy production is going to be in the future. So we're using the current values. Again, I'm using these generation values to drive the model. And so here's one of my peak years for operational impacts. And again, in that year, given all of the additions that occurred, it created just 728 jobs in operations. Labor income, by the way, if you divide this by that, you can see these people make really good money, way more than I do per job. Value added, and then the output. Again, they needed inputs, and you can see they have a strong inputs multiplier. The number of jobs in the in supply sectors is almost 3 times or more than 3 times higher. So they have a strong demand for inputs, and they're mostly technical inputs, mechanical inputs, maintenance inputs, repair inputs, those types of inputs that go into these new systems. And then again, the induced activity, and you multiply it all the way through. So in each one of these years, 31 and 32, this is what I estimate was added. And again, these jobs now are additive. They're cumulative. And I'm building up to a total number. So yes, my total was 2.6 billion, of which was 1.7 in value added, 463 million in labor income to almost 6,000 job holders. Again, I've summed this up over the stream for each one of our technologies as the jobs are being created, as the capacity comes online. You'll notice I'm lagging it by 1 year. I build 1 year and I come online the next. So I'm lagging it by 1 year. Everything then peaks at 2040, and then it stays that way so long as this installed capacity is still working. And so I have my jobs totally all the way over to the side. It's 83,819 jobs get generated in total, all the way multiplied through. All the way multiplied through. And let's work our way through this. This is what it looks like. This is wind, operational jobs, plus solar, plus the natural gas, which mostly all occurred at the beginning. And then the transmission jobs. And transmission jobs, there's not very many transmission jobs per $1 billion of investment. They're very lean on that side, according to the NREL data. But we can see the total economic activity then by the 2040 and thereafter for the sum of all of these. Again, this is almost $34 billion worth of output is being generated, $23 billion in value added, $7 billion in labor income, 84,000 jobs are generated 2040 and thereafter. So that ends up being the capped value. That's what it grows to. But I have to take some jobs away because we're closing some plants down. And we're closing primarily fossil fuel generated plants. So those are being closed on some regular schedule. Again, it was determined by their modeling. And so we have these closing down over this same time period. And just by comparison, here are the additions. You can see early on, we have more closing than we have new capacity coming on. But eventually it picks up. Now, we have a problem with it, or it's not a problem, but it's one of the problems that we have to address with regard to this. When we close these fossil fuel systems, we have a multiplied through upstream impact into whoever is supplying them, whether it's gas or whether it's coal. And it's relatively strong. We're adding a lot of systems whose feedstock has no labor associated with it, sun and wind. They have a different mix of inputs. And so when we close these systems, they have a stronger per closure multiplier effect for a while than the per opening multiplier effect of the new systems that are put online. So what we end up with is here's what's coming online with the new jobs, with the new investment. Here are the losses due to retirements. And in net, we actually get on the operational side a net reduction for a period of time, until it comes out positive in the last 4 years. Now, and no value judgments here, but these are losses. These are losses, and they have to be acknowledged. Where they occur, I don't know. When they occur, we do know, right here. Now, I can whitewash this or wash it away. I can say, well, here's all of the construction-related jobs, and then here's all of the net job gains associated with the retirements, making sure the retirements are factored in. And then this is the net growth overall. You know, we can dwarf this, but it doesn't dwarf the fact that this is going on. Whoops, I did not mean to do that. There we go. But this is still, nonetheless, what we would expect over the construction period in terms of job creation. Let me move on here. Just a reminder, I'm going to compare now scenario A and scenario B, the current policy with the carbon policy. Again, you can see the values that are up there, and this is just this. We're wrapping this thing up. This is what it looks like with scenario A in terms of total job growth associated with the construction activity. Remember, these are temporary, and they only occur during the period in which construction activity is taking place. The carbon policy, much higher, much bigger number. Much bigger number. Here's what the cumulative operational jobs look like. This is the scenario A, the current policy. Scenario B, they go to that. And then, of course, I have to net them out. And so this is what it looks like under scenario B. Or scenario A, we're negative until we start climbing out. And then in the last 4 years, we come positive. And then we level off. And then here's scenario B, the carbon policy. This is what the job impacts would look like there when we add them to the thing. That is my presentation. If you want to talk to me about this or contact me about this, please do. And do we have time for questions?
Yes, sir, we do. Thank you for your presentation. I'm Helena Kasduzian. I'm a postdoc at Ames Lab. And I think that this job discussion is one negative externality to be considered from this bigger study. Are there other externalities that we should be considering as we think about this Transgrid project?
And I will ask the audience to help me with that. But are you talking about just the operational jobs as a negative, the losses, or?
Right, but that's the one potential negative externality. Are there other?
Yeah, there's going to be geographical offset. Who's gaining where? Who's losing where? That's also an aspect to that. Who has advantages with regard to supplying the inputs that are critical for these things? Again, there's going to be a distributive aspect to that. It's not necessarily negative, it's just who are the winners and losers. And I can't tell you who the winners and losers are from what I did here, but what I can tell you, that a large fraction of the high-value, durable inputs that go into what they've anticipated here would come from the industrial Northeast Midwest, Ohio, Indiana, places that aren't even on, there's no generation going on in those places, New York, Pennsylvania. So, you know, the gains of this thing get distributed widely, even though where the economic activity might be taking place is highly localized, oftentimes highly localized.
Other questions?
Lots of them.
You know, it occurs to me, and this is sort of an observation more for utility folks. These numbers to me emphasize how lean the utility industry operates. If you run those numbers, what is the U.S., a $13 trillion economy? Mm-hmm. If you run roughly, so that number of jobs is about 4% of the total employed economy. Mm-hmm. If you run that impact through and compare it against a $13 trillion economy, that's like 7 million jobs, just in terms of the aggregate impact on the economy, and we're doing it for 500,000.
Yeah, the energy generation, I think, has about 160,000 jobs total at those operations. And it's been going down 1% a year for the last 8 years. So over time, you are using less labor to produce more electricity.
Dave?
Yeah.
Fred Fletcher, Power from the Prairie. I was wondering, in your numbers, does this have implicitly show some of the value of creating a new technology? For example, once they start building all these wind things, that creates factories here that will make the...
Yeah, he's asking whether, if we start doing this, do we start creating additional, we actually shift the supply chain down to where this economic activity is going. So we had blades and we had bases. And that's happened here in Iowa. We have 2 places that make blades. We have 1 place that makes bases, and we get the manufacturing activity. So the answer is in part. And are they going to make bases in western Nebraska? Maybe, maybe not. Are they only going to be made in Mitchell, South Dakota, but they're going to distribute them as far as they can out of Mitchell? Maybe, maybe not. It depends. But some of the things won't be. The high value stuff that goes into these systems oftentimes won't move. But the big bulky things, they will move. So there's things that you could anticipate. High value, high dense, like the nacelles, the generating equipment. That's not going to get made in Nebraska.
But the big stuff could be.
Well, but the blades will be, because they're bulky and
they're hard to sell. They're hard to move.
You have trouble moving them long distances. Yeah. And the same thing with bases. So, with regard to that. So it works with regard to that. With the natural gas additions and the solar additions, that technology is pretty straightforward and highly specialized, so it doesn't have the big bulky parts and that, from what I understand. But there's a part of it. I did some of this stuff a decade ago, and I had this fight with the Union of Concerned Scientists because they wanted a blade factory and a base factory and and everything else, in every state, when we did this, and I said, it's unrealistic. We need to be realistic about some of this, but some of it could occur. And again, if it occurs there, it's just shifting from someplace else in the nation. Or it's adding capacity in a place.
It's not shifting because nobody's building these blades today.
Well, yeah, if this is additional capacity, it would just be shifting that, okay. Yeah.
One other question. Any questions? You got it.
I was just thinking, the fact, there's two issues here that look like, to me, they are really substantive that we need to dig into further. One is the distribution of the, I forget what you call them, secondary and induced effects.
Indirect and induced, yes.
And where those go.
Yes.
It would not necessarily be, and probably related to this gentleman's
Yes.
talk, it would not necessarily be in the same place where the generation facilities go.
Right.
And that tends to mitigate the winner-loser perspective a bit.
That's the point I was making about Ohio and Indiana.
And the other one that is not here, that everybody needs to realize, is the reduced price of energy in certain locations, and that has an economic effect.
Yes, it
And
does.
we're not accounting for that in
No,
this
this
analysis.
model can't do that. This model is not that smart, and neither am I. But there are good models out there that can do that, and we can estimate what would be those feedback, price changing, and income inducing aspects to households.
And that's the Phase 2A report you're going to be putting out in the next 6 months, though.
He gives me a
No, it's
month
important that we have
notice.
that information.
Yeah, I'll just build off the young woman's remarks on other externalities. I think what she was asking for, at least in my mind, I hear that is,
Yeah.
are you looking at local air pollution? Are you
Oh.
looking at healthcare quality, et cetera? So
Okay,
it's not
Yeah.
your study, but if folks who are here are interested in that, as there was a comment this morning about placing it in that context, talking to some of the folks in the public health departments who actually can do those local regional air quality and health impacts and or economy-wide impacts is also a possibility. They would love to collaborate, take the inputs or the outputs of the models as they have been done and run them through their analyses. Just adds very other perspectives to bring to the table, again, through quantitative, kind of rigorous academic analyses.
Thank you. Well done.
Okay, let's give Dave a hand.